Good afternoon. Good morning, everybody. My name is Mike Ungar, and I'm one of the co-founders of the Industry 4.0 Club. The Industry 4.0 Club, our purpose is to advance the deployment of Industry 4.0 for manufacturers really across the globe. We do that by hosting conversations like this and also helping to program live events. I'm really excited today to speak with our guest, Deep Singh. We're going to talk with him in just a minute. Just a bit about myself. I spent 35 years at Michelin North America in a variety of continuous improvement, operations, finance, and HR roles. Today, I'm a business coach and executive coach, helping business leaders achieve their full potential. So really excited today to be speaking with Deep Singh. We're going to talk a little bit today about additive manufacturing, and so excited about that. So Deep has over 10 years of experience as a technology executive, professor, and entrepreneur, and is a passionate advocate for the transformation of manufacturing industry through additive and digital technologies. As the Vice President of Advanced Manufacturing at CAD Microsystems, Inc., Canada's largest Industry 4.0 value-added integrator, he leads a team of experts who provide end-to-end solutions and services to help his clients optimize their operations and stay ahead of the competition. Deep is also the co-founder of an additive manufacturing startup and a professor at advanced manufacturing technologies at Ungar College, where he shares his expertise and knowledge with aspiring mechanical engineers. I can't wait to hear more about that. He holds certifications in engineering technology, SME certified additive manufacturing professional, and application engineer certification with various advanced manufacturing OEMs. And he's also published several papers on additive manufacturing applications and received global recognition for his design and innovation. So, Deep, welcome. We're glad you could take time out of your schedule to talk with us today.
Yeah, thank you very much, Mike, for having me. This is a very exciting topic, very close to what I do every day, advanced manufacturing, additive manufacturing. So thank you. I'm very grateful for you guys decided that I should be part of this fireside chat.
Yeah. So if I can ask Deep really quickly. So one of the things I know people were going to wonder, Deep is a typical name. What is the name? What's your given name? And Deep's kind of a nickname for you, isn't that right?
Yeah, so I try to make things easier. That's what I do, right? That's what technology does. So my name is Hargurdeep Singh, and often I find sometimes people have challenges pronouncing. So if you want to pronounce it, you break it down. So it's Hargurdeep Singh.
Hargurdeep.
Yeah, and then you can call me Deep. I'm comfortable with that.
Perfect. Well, just in case people want to look for you as we, and figure out who you are, that way they know that. So thank you for that. So I got a chance, when we were getting ready for this conversation, I got a chance to look at your resume and notice that you've been really active in leading several initiatives. Really, I mean, as a leader, going back to the days when you were in college. So tell me, what motivated you to take on these different leadership roles so early in your career?
Yeah, Mike, actually, it goes way back when I was maybe 5 or 6 years old. My grandfather and my grandmother, they really were the driving force in encouraging me to do a lot of public speaking at that age. Anytime there was, a family ceremony, they always made sure that there was, good 20, 30 minutes reserved toward the end. And I was always given the opportunity to go onto the stage and share like a story or some sort of dialogue. So at that age, I got quite comfortable speaking in public. And then my family and I, we migrated to Canada when I was 10 years old. Like any immigrant family, parents have immediate responsibility to start providing food on the table. So my mom and dad were working extremely hard. They were working in the factories, and my dad was trying to build his pizza business. So during that time, I would spend a lot of time by myself, kind of growing up, but also getting into the occupational role at a quite an early age. So I remember as early as when I was 12 years old, I was delivering newspapers door to door. And then every time, summer holidays came when I got past the age of 16, I was working in the warehouses. I
Wow.
had my forklift license. So that journey that often starts after you graduate, I had that started in a very early age. And then the leadership side came when I went to the college, and one of the professor encouraged that, I asked him a question around, where's your engineering association? How do students kind of come together? Kind of what you do at Industry 4.0 Club is how do like-minded people come together and come up with initiatives and ideas and concepts and competitions. And we didn't have any of that culture at that point. So
Wow.
his encouragement was like, go ahead and start it. And and so that little bit of a push really helped me kind of take my first steps into leadership.
That's yeah, that's really neat when you describe that. I think it is a reminder for everybody listening, and you never know the impact you can have on somebody else by just creating that little push, right? So a lot of times I think we underestimate our influence on others, and it's really neat to hear you talk about that professor that pushed you a little bit. I mean, it served you now, I'm sure, through your career so far. And I guess I just remind our listeners that you have people that who sometimes just need a little bit of push. That's really interesting.
Yeah, and recently we were at an event together, and the professor, he was my dean at the time. He was the host of the event, and I was sitting as a panelist, and right beside me was the dean that hired my dean. So it was like a full closed loop system. It's incredible how kind of it all comes together.
That's really neat. That's
Yeah.
wonderful. Hey, as we're moving forward through our conversation today, I just want to remind our listeners on LinkedIn Live, if you have a question for Deep as we go along, please put it in the comment section there, and we'll get a chance to see it, and we'll get a chance to pose that question to Deep as we talk today. So, well, that's great to hear about. It's great to see and really hear you talk about one of the folks that had such a significant influence on your life. But you've done a lot of things already, in I guess I'll call a short time because I guess I have a longer work history than you do. But what are some of the accomplishments that you are most proud of thus far?
Yeah, so every time I hit an accomplishment, for me, it's more around what's next, right? So as I was reflecting through this question, I was thinking about some of the things that I'm proud of, and often, you don't think about the moments that you're proud of something. You think about, okay, what's the next initiative to take? So I say some of the things that I'd be proud of is, if I reflect back, I'm extremely proud of leading an engineering team when I was in college at the time, and we competed globally with American Society of Mechanical Engineers in a global additive competition, and when we received the first place recognition for our 3D printed wind turbine blades at the time. So that propelled my excitement into additive. So that was sort of the starting point for me to get motivated into the additive space. Then moving forward, as I'm leading the advanced manufacturing division here at CAD Micro, I'm really I feel very honored and I feel very accomplished when I get to help clients, right? So enabling Canadian innovation has been by far the topmost mission of myself, and when I see clients understanding applications for additive manufacturing for digital processes to help them reduce costs, mitigate risk, and increase their profitability efficiency, those are some of the things that I'm really proud of. And then finally, I'd say, my wife and I, we just recently published a children picture book right behind me. It's called the 3D Printing Adventure, and that's a moment that we were extremely, happy and proud that we're creating a environment for kids that are between age 5 and 10. Like I was impacted by my grandparents. Is there an impact that I can put on someone at that age group? So that's a proud moment for me.
So for the book, does the book is the book accessible on like Amazon or other places?
Yeah, it's accessible worldwide. Amazon's available. It's called the 3D Printing Adventure, and it's a nice picture book. It gets kids excited about innovation.
That's really cool. You mentioned leading a lot of groups. I kind of want to follow up on that a little bit and understand from a leadership perspective, what are some of the leadership principles that you have learned that you'd share with others today?
Yeah, I think the biggest one for me is adaptability and understanding that not every member of my team is going to be the same. So the approach you have to take with your team is very personalized. You have to understand their personal missions, personal visions, personal objectives, and then you can build a program around them to be successful. So adaptability has been by far, um, I guess, the biggest skill that I had to kind of learn over the years to be successful and to make my team successful.
What you're describing is similar to one of the things I think about a lot, and that's when you did with a team, you want to kind of organize around their strengths, right? So
Absolutely.
I think the term I've used before is strength-based leadership, where you don't try to put them in the box that you want. You try to figure out what their skills are, and try to build a team that complements them. So I think that's really cool.
Yeah.
Um, that's really neat. So I know you talked about one of the things you also just mentioned about your accomplishments, which I like to help clients, and you're really targeted. I think you mentioned your goals to enable uh, Canadian manufacturers' competitiveness. Is that right?
That's right. To enable innovation. So, to help them understand that, where is the innovation that could play a role in their organization to be profitable and to reduce risk and to mitigate any challenges.
Yeah, we have our first question. And I think it's along those lines um, from one of our listeners. So it really goes back to this idea of advice. So what advice do you have for small Canadian manufacturers to help them with their competitiveness today?
Yeah, no, so fantastic, right? So I guess the number one thing that I notice in the field is often I define as a tunnel vision. It's what that means is, we have to continuously challenge the status quo. We cannot rely on things that do not give us result, and we repeat them over and over again. Engineers are smart people. I've gone through training myself. We're trained in a certain way to be ethical. We're trained in a certain way on logic and mechanism. But there's a business decision that also has to impact the organization for it to be competitive. And often that conversation has to get past, this is how we've always done things and this is how we're going to always do things. So, create an environment in your organization that fosters innovation, and innovation is going to allow you to be more competitive as you move forward.
Yeah, that's great. That's good advice. Not just for Canadian manufacturers, but for any manufacturer. So that's fantastic. Well, no, it's very interesting to think about those things broadly for sure. So I want to kind of turn our conversation now to kind of the topic we have a little more towards the topic we have for today's talk. Um, and talk a bit more about additive manufacturing. So, um, well, first of all, maybe you could define what it is for our audience. I'm assuming everybody knows, but that's sometimes not a good assumption. So, could you define what additive manufacturing is from your perspective?
Yeah, so often, there's a mix up between additive manufacturing and 3D printing. Okay, everybody understands 3D printing, but when you think about 3D printing, your mind immediately goes to an extrusion-based 3D printer that may be sitting in a makerspace that prints out of plastic, effectively a hot glue gun on a CNC machine, is how I define it. Um, Additive manufacturing is a broader term. It covers seven different processes that have many different materials, many different capabilities. But essentially, ASTM defines it as, additive is a process of building object layer by layer, as opposed to a subtractive process where you're removing material.
Ah, okay, that's logical. That makes a lot of sense. The term. It's funny how sometimes terms actually fit what they're supposed to.
That's right.
That's really cool. So, what are some of the innovative ways that you're seeing companies today use additive manufacturing?
Yeah. So early on, when, additive has been around for over 30 years, but initially additive was reserved for um, design iteration. So, to be able to make prototypes for fit form type of applications. Um, then you see an evolution around manufacturing aided tools, jigs, fixtures, tooling. So you're now evolving with your material capabilities and so on. Now we're starting to see rapid manufacturing. So we're starting to see that material capabilities, the precision of process, the repeatability, reliability is improved significantly over the years. And it's now complementary to existing tools. So you can use it for end use applications for small to medium volume manufacturing. Um, Often when we do sell equipment, and service and support our customers, we'll ask them if we can showcase their projects and do some sort of marketing activity around case studies. And 9 out of 10, I get a no. We don't want to share with the world that what we're doing with Additive because it's a competitive tool, right? So there's a challenge around sharing the innovation around where companies are leveraging, but generally they're leveraging in three different domains, and I define them as three R's. So you have rapid prototyping, rapid tooling, and rapid manufacturing.
So, so I know additive's been around for a long time, right? Since the 80s. Which came first, the prototyping is that what really how people started with prototyping?
Yeah, prototyping is what came initially in the 80s, and the material capabilities were very limited. The process capabilities were very limited, so you were sort of restricted to a functional end use part. You were more focused around fit in a form type of testing from a prototyping standpoint.
So the three P's again:
prototyping, tooling, and then rapid manufacturing.
Tooling and rapid manufacturing. So let's talk about rapid manufacturing for a second. That I'm guessing that was probably came along, the third of the three. Am I thinking that correctly?
Yeah, you're absolutely right. That was the third, yeah.
And so tell me, what are some of the advances that have been made there in particular, and are there any case studies you can share?
Yeah, so effectively, when you think about additive manufacturing, fundamentally the process is sustainable because you're adding material as you need, with the exception of very little waste. Maybe there's some overhanging support structures, but you can design around those and have design for additive manufacturing practices in play. So from a sustainability standpoint, additive is quite beneficial. But effectively, the complexity we can design in additive manufacturing for rapid manufacturing, that's been a key enabler. If you look at traditional parts, they're very parametric, right? They're block-like structures because for subtractive process, anytime you add features, you're adding more cost. With additive manufacturing, the term often gets used as, the complexity comes for free. The more complex your geometry, the more benefits you're going to get from additive manufacturing standpoint.
Wow.
So if you think about, your customized hearing aid, right? Everybody has a different ear canal. So, you now can 3D print customized hearing aid. Think about missing limbs, prosthetics, orthotics, um, you know, dental aligners, all of that from a medical care perspective. You can now mass customize rapid manufacturing.
That's
Um,
that's neat. So, which industries are adopting rapid manufacturing, more quickly?
Yeah, so there's definitely healthcare is for sure. There's a lot of activity happening in healthcare. Automotive, aerospace are also doing a ton of work when it comes to lightweighting applications for manufacturing, as well as consumer goods. Right, I was at Germany last this month actually, and some of the amazing innovation that came together at Formnext was an eye opener. There was about 350 exhibitors that are just focusing on additive around the world that were at Frankfurt. And there's stuff like anywhere from bicycle seats to satellite parts. The spectrum of where additive is being used is so broad.
You mentioned earlier that 9 of 10 companies, or approximately, you talk to, don't want to share what they're doing because it's proprietary. And yet we know that open source innovation is what allows us to advance more quickly. How are you bringing those things together from your own perspective, or how do you see that coming together?
Yeah, so this is very interesting. So I had a similar conversation with a company in Germany, and they're a 100-year-old business, uh, started from forging business, okay, and forging they're taking aluminum parts and they're forging, and now they're into additive. So they got a division that's additive. So one of the things that they highlighted was that in the forging business they have 4,000 different metal alloys that they work with. In additive they probably have about 20. So there's this whole evolution of material process development that's happening because the equipment manufacturer is interested in selling the equipment. The material manufacturer is interested in selling the material. So there's that gap in between. And there's a lot of research happening. I mean, in Canada, we have University of Waterloo. They have an MSEM campus. They do a lot of research around process parameter development. But
Hmm.
all of that IP in every part of the world is sort of reserved to companies. So what this company in Germany has done is they've created a spin-off out of that. It's almost like a marketplace for process parameters. So you can be anywhere in the world as long as you want to contribute. You can contribute these process parameters, these marketplace, so that you're not reinventing the wheel. And if you think about just a couple months back when we were in the middle of the pandemic,
Yeah.
if we weren't sharing the innovation, if we weren't sharing face shield designs, if we weren't sharing ventilator parts, the chaos would have been a lot different than what we were able to control. you know, I remember communities developing face shield designs that were made on desktop 3D printers or additive manufacturing equipment that were
Yes.
shared like a digital fax, you know. So I think it's important to share innovation. I think we have to absolutely preserve some level of IP, but we have to be mindful of, what value this IP is going to bring to the society around us as well.
Yeah. Thank you for that. And I think it's a real interesting challenge, to maintain a competitive advantage, but at the same time, though, even for those individuals who have that IP, we know that if they can be open source, they're going to advance more quickly themselves with the next advancement. So it's kind of a catch 22. It could be a catch 22, but it doesn't need to be. I guess is what I hear us talking about.
All right.
That's wonderful. That's great. So if you think about the next 5 to 10 years, so what do you think some of the evolutions will be in this area of additive manufacturing, and what will their impact be on industry? I mean, I'm going to ask you to put your crystal ball on the table for this one. I know, but
So there's a couple things that I think are going to happen. One for sure that's right at the immediate is, how additive is going to interact with AI, right? AI is starting to challenge us, especially as a professor. I can see, the content that we receive is influenced by AI sometimes, and we have to embrace that, right? So it's no different than when the calculator got invented and everyone was used to doing things manually. So this new tool is out there which is challenging and encouraging people to design in a very creative way
mm-hmm.
that traditional manufacturing is not suitable for. So it's going to increase the adoption of additive manufacturing. It's going to challenge the material, the capability, the process, the precision of additive manufacturing. So the integration of AI, I think, is going to be interesting. I think the other thing is going to be interesting is uh, from a predictive maintenance standpoint, AI is going to be involved in understanding the downtimes of your processes and know when you're going to incur downtime in your equipment through that process. And then so that's the AI integration. The other thing I think is going to happen is the integration with other Industry 4.0 tools like big data. So in order for AI to be efficient, you need to be able to get telemetry data from your hardware. So hardware manufacturer companies are going to start to incorporate more sensors on their equipment that do not exist today
Mm-hmm.
to gather that data. Cloud connectivity to be able to access your equipment no matter where you're traveling. We have now this hybrid work approach, that, especially the real estate market in Toronto has gone skyrocket. So, people still need to work. So to be able to share that through cloud connectivity is going to be enabling that integration of additive. And then fundamentally, the material has to evolve. We still have a long journey for materials to be relatively repeatable, reliable, and expansion of that portfolio. So I think there's a lot of work ahead of us. And then couple that with simulation tools. How do you have a confidence in 3D printer part or additively manufactured part? You should be able to get some sort of data on simulation capabilities that says, okay, if you manufacture this using additive or any other processes, this is the likelihood of a success rate or failure points.
Yeah, interesting. That's really cool. Um, Along the same lines, though, I guess, I'm trying to think about, today there aren't a lot of, 3D printers. I mean, there are some, but they're not, as common. So, how do you think about the future of 3D printers? Will they be more I'm going to use the word traditional manufacturers, aerospace, automotive, using a lot of additive manufacturing in I'll call it routine production. Do you see that being something in the near future, or what's it going to take for us to have a breakthrough where that really changes? To, where the parts are made from additive manufacturing, not as you mentioned before, subtractive manufacturing.
Yeah, no, absolutely. I think, again, if we go back to the pandemic time, right? Injection molding, eventually the face shields that people had were injection molded, the nasal swabs were injection molded, right? But that process took several months to kind of uh, be ready for the demand. Additive kicked in, right? Right away, people were um, fabricating these devices, these medical devices, using additive manufacturing because that was the most efficient way to go to the market quickly. And then eventually, from a cost reduction standpoint, other processes made sense. So I think one is its realization of the value that additive offers in the toolkit that manufacturing companies have,
Mm-hmm.
right? So if you go to, you mentioned aerospace companies, if they have a machine shop, I'm sure they're not just doing everything with a hammer and the chisel, right? They got CNC machine, they got lathe machines, they got many different processes and equipment. Just like that, additive provides a value in that manufacturing segment, and that all of that realization is going to happen from an education standpoint. So as our engineers, as our business leaders are coming out of this institutional change, they need to understand the value that each of these processes offer, that they can then implement downstream. And designing for additive manufacturing also is going to be critical to realize the efficiencies and the benefits of additive manufacturing.
Yeah. So when you say designing for additive manufacturing, what does one do differently when you think that way?
Yeah, so if you think about a subtractive process, right? We talked about this in terms of you're removing material. Often you want to remove just enough that you're able to deliver your functionality. Anything you add extra to reduce weight, you now have to think about its added cost because you're now subtracting more material.
Mm-hmm.
In additive, I'm challenging some of my students. I'm like, the conversation we have in house is think additively. Do not constrain yourself from traditional manufacturing bounds. Think about ways on how your part is going to be able to serve its value, but now all of the extra mass you have, you get rid of that mass. So you're maybe doing generative design or topology optimization to have a function-driven part, not necessarily a block-like part that you're used to from a subtractive process.
Hmm.
So it's going to take thinking additively to kind of get there.
And how about materials? Are the materials prepared? Do we have the material for additive manufacturing that would allow us to do that once we started thinking more that way?
Yeah, absolutely. So, in the additive, you have 7 different processes. Each has its own benefits, its process, and so on. But if we just narrow in on, if you think about powder bed fusion, that's dealing with powder and a laser is melting, or you're using agents to solidify the polymers. That process becomes closely isotropic and predictable. So there's material capabilities that are happening in that space. If you think about DED process, direct energy deposition, you're now using that for colliding existing tools that could be used for down drilling hole for oil and gas to
Mhm.
extra reinforce your metal tooling.
Wow,
So so it is evolving. I mean, SpaceX they additively manufactured a rocket and did a full launch. 80% of the rocket was additively manufactured. So we're getting there.
that's neat. No, I did. You kind of don't realize. I mean, if you're in a traditional, manufacturing environment, you don't realize what's happening there. That's pretty neat stuff.
Yeah.
Well, I wanted to segue into something else from what you hit on. You mentioned earlier in just the last couple of minutes about you referred to your students, and I think it's real interesting because as a university professor, you interact with lots of mechanical engineering students on a regular basis. So, talk for a minute about talk about the what you're seeing out of the students in school today. Are they, what's different about them than maybe when you went to school? Uh, can you talk about those differences now?
Yeah, no, absolutely. I think the challenges they still remain the same. I'm dealing with final year students, and so often when they're in the final years, they're concerned about are they going to land a job? Is there going to be a career at the end of the 4 years or 3 years that they've spent in academic, right? My job as a final year student professor is to open them up to another tool and challenge everything that they've learned till the final year and say, that's great, you've learned all that, but now I want you to think differently. I want you to think additively. And often I find it's a struggle, it's a challenge, right? But as they go through the journey of the program and they start to design and optimize topology, they start to play with lattice structures, they start to um, understand that additive is not just one type of 3D printer, it's many different processes. They start to imagine the possibilities. And this is what happened to me when I was in my final year. I asked my dean, my professor, the one who's been an extreme mentor to me, and I asked him, I sent him an email, and he referred that to every conversation we had. He said, you've been helping me in this direction of additive manufacturing, but I feel like you ruined my career. You ruined my chances of success. My email to him was not a very pleasant email,
Right.
and he has it printed and he saved it. He's like, every time we talk, he's like, I have it saved and it's there. I look at that every time. And my ask to him was, back in 2014 when I graduated, I said, I'm looking up for jobs for additive manufacturing engineer, technologist, and guess how many jobs that we're seeing? Zero. And I'm like, you've provided me with this tool, you've provided me with this excitement and passion for this industry, but there's no jobs. And then his response was, Leap, I'm training you for 5 years ahead of time and not how we're doing things today. And today I'm very thankful that I took that leap of faith and I went towards additive because I've
Right.
been extremely successful in my career. So that's a journey, that's a personal journey I share with my team. But my takeaway for them and what I say to everybody is you lead with curiosity. Lead with it. If whatever you're passionate about, lead with your curiosity. But you have to promise yourself that not that you don't get carried away by leading in curiosity. You have to execute with excellence. That's often where the failure point happens. Is
Ah,
that we get very excited, but we're not executing it with excellence. So that's it.
that's neat. No, so um, don't be afraid to. I think what I heard you say is don't be afraid to get outside the box a little bit.
Yeah.
Okay, and get excited about something, and then be excellent as you move forward. That's pretty good stuff.
Yeah.
Um, do you see, and our students, if you look at a class of, I don't know how many students are in a class you might have of 15 students, how many are motivated by that, or how many are not? They're still risk averse. What do you see? Are students willing to take that leap with you?
Yeah, so some of the students have come during our evening discussions. They've raised that they want to go into additive. The additive has gotten them excited. They're motivated, and where can they find opportunities? I'm hearing a lot of that through that discussion that comes out of after the class. I tell them that right now it's your opportunity to be a sponge. You go and you learn as much as possible, and then you figure out your path as you're learning. So your education doesn't really stop here. This is the foundational level that we're building. Once you get into the industry, there's going to be challenges you're going to come across, and that's when you're going to be like, I know. A professor taught me that this challenge, this part that I'm trying to manufacture, additive manufacturing is going to be a better fit for this application. And
Yeah,
then they start to evolve in that direction.
that's cool. One of the things that in my career, I spent time in recruiting and read a lot of resumes. And I'll be honest with you. For me, you know, and then we're talking a very technical topic, but for me, I used to really want to discover if the student learned how to learn, even more so than they learn a technology. Because, I think back to the days when I first started in manufacturing. Don't laugh, but we had one computer in the plant. Okay, and now look where we are in all manufacturing environments. I mean, and our phones. My phone has a whole lot more power than that computer did way back when. And so, I know in my career I had to learn a lot of new things as I went along. And so I think that's one of the other key things that I just would add is, for students is make sure you learn how to learn. Get excited, like you said, about a topic and that's set on the future, maybe not so much on the present, but learn how to learn.
Yeah, I often say learn how to unlearn, because often we get in our own ways. If we're trying to be innovative, we have to learn how to unlearn as well.
Yeah. Well, no, you're right. And the comment of adaptability is absolutely key, because um, even today, in the last couple of years, I know I'm still doing things that I didn't do 2 years ago.
Right.
And I think that's part of, if you're through your life, it's how things go.
That's right.
Things are changing at a pace today that and it continues to accelerate faster and faster. So that's really neat. Well, we've been talking now for quite some time. And again, if anybody who's listening in has another question, please let us know and we'll be glad to pass it to Deep. Deep, as we begin to wrap up our conversation, though, I wanted to see if you had any last thoughts for our audience on additive manufacturing that might be of interest to the group.
Yeah, I think with any kind of adoption to new technology, the pathway is usually unclear in the beginning. But I think it's an opportunity for companies to, like we said, learn to unlearn. Challenge the status quo. If there's challenges you're having in your manufacturing today, if there are, processes that are not working, you're not able to deliver parts to your clients fast enough, you're not able to provide design freedom and flexibility, then maybe it's time to look at a different tool in your organization. And additive could be that tool that allows you to continue to be profitable, continue to be agile and adaptive to your clients' needs.
Yeah, thank you for that. That makes a lot of sense. Well, I appreciate the time. It's been really great to have this conversation today. We've been speaking with Deep Singh. Deep is, as I mentioned at the start, a technology executive, professor, and entrepreneur. And we spent the last, almost 40 minutes now talking about his experiences, what he's learned so far through his leadership roles, and really digging deeper into additive manufacturing and how manufacturers should maybe pay attention to that technology or that approach to manufacturing. So I appreciate the conversation, Deep, tremendously. So if you like conversations like this, we've been talking this last 40 minutes with Deep as part of our fireside chat with the Industry 4.0 Club. The Industry 4.0 Club's mission, as I mentioned at the top of the time together, is to advance the deployment of Industry 4.0. We do this through conversations that we hold weekly. We speak about women in manufacturing and bring on some very interesting guests there to talk about their roles. We talk about technical topics focused on technology and the future of manufacturing. And we do many fireside chats like we had today with Deep. We'll also speak about people, process, and culture. The Industry 4.0 Club also is involved with programming for live events. Our next live event will be at IME West, which will be in California in Anaheim, February 2nd through the 4th. And that's hosted by Informa Markets. Again, Deep, thank you for your time today, and thanks to our audience for taking time to join us. Have a great day.